So let's start with number 1. So this is in standard form. We can find the vertex when it's in standard form using negative b over 2a, where our coefficient of the x squared is our a, coefficient of the x is b, and then the constant is our c. Now before we find the vertex, let's just answer the question, does it open up or down? Up. How do we know that it opens up? A is positive, so that tells us that it opens up. So we have a parabola that opens up. Now let's find our vertex. So negative 1 over 2 times 2, which would be negative 1 over 4. So that is our h in our vertex, the first number, negative 1/4. How do I find the k, the second number in our vertex? We could do that. How else could we find k? Anybody remember? So we can take our h, which is our x value in the vertex, and plug it into the x's in our equation here. You can do, Jade, what's the formula? C minus b squared over 4 times a. This works. You'll end up with the same answer, but it's just another formula to remember, so I would just recommend plugging in your h into the x's to find the k. So we have 2 times negative 1/4 squared plus negative 1/4 minus 3. So this would be 2 times 1 over 16, which would be 1/8 minus 1/4 minus 3. What do I need to add with fractions? Common denominator. So I can make this 2 over 8, and then I can make 3 into 24 over 8. So 1 minus 2 would be negative 1, minus 24 would be negative 25 over 8. So that would be our k in our vertex, negative 25 over 8. So in our vertex, we use negative b over 2a to find the first number, and then plug in h to the x's to find k. Our axis of symmetry is always x equals the x from our vertex, so negative 1 over 4. So axis of symmetry is always x is equal to h from our vertex. Now we said that our graph opens up. Is our vertex at the highest point or the lowest point? No. The lowest point. So would it be max or minimum? Minimum. And what is our minimum value? It is always the y value, so negative 25 over 8. This should be domain. What's our domain? Negative infinity to positive infinity. It is always all real numbers for the domain. Always, always. So your other domain is going to be negative infinity to positive infinity. That is like a free question. No work required for domain. Now our range. Our range deals with the y value. Is our graph going up to positive infinity or down to negative infinity? Up. Up. So our graph is going to go from, what's our y value in our vertex? Negative 25 over 8 to infinity. And the number always gets a bracket. Any questions so far? All right, now for our x-intercept, we plug in 0 for y. For our y-intercept, we plug in 0 for x. So let's find our x-intercept first. So we're going to plug in 0 to the y. So 0 is equal to 2 times x squared plus x minus 3. What do I need to do to solve for x here?
You multiply 3.
Awesome. We're going to have to factor. You can either factor or use your quadratic formula. By factoring, or when we factor here, we need to multiply the first times the last because our leading coefficient is not 1. So we get negative 6. Do we have two factors of negative 6 that add to 1?
Yeah.
What are they?
3 and 2. Negative 2.
3 and negative 2. Perfect. So x plus 3 and x minus 2. What do I have to remember to do next? Divide. Don't forget, if you start by multiplying, you have to remember to divide. So we get 2x plus 3 and x minus 1. Then we solve both of these, set them both equal to 0. So we get x is equal to negative 3 over 2 and x is equal to 1. Now our x-intercepts are points. So our x in our point would be negative 3 over 2. What did I plug in for y?
Infinity.
0. I plugged in 0. So my point's going to be negative 3 over 2 comma 0 and 1 comma 0. We have two x-intercepts, so we cross the x-axis 2 points. So we have negative 3 over 2 comma 0 and 1 comma 0. What if this didn't factor? What would I have to do?
Quadratic.
Quadratic, if it didn't factor, which is negative b plus or minus the square root of b squared minus 4ac over 2a. What if I ended up with a negative under the square root? What does that mean?
Imaginary.
Imaginary. So if it's imaginary, then would I have the x-intercept?
No.
No. So if you end up with a negative under the square root, it's no x-intercept.
So we just put no?
Yeah, you'd say none. No x-intercept. So if it doesn't factor, you can try using the quadratic formula. If you use the quadratic formula and end up with a negative under your radical, there's no x-intercepts. You can also kind of get an idea if there's going to be an x-intercept by graphing. Our vertex goes to the left to negative 1/4 and down negative 25 over 8, which would be like 3-ish here. And then our graph goes up, so we know we're going to have x-intercepts. Our graph crosses the x-axis. If our graph were to be if our vertex was at this point and our graph opened down and we don't touch the x-axis, then you don't have x-intercepts. So you can kind of think about it either way. You can picture the graph or do the quadratic formula.
How do we know if it's not touching the x?
Let's say, just as an example, if our point for our vertex was here, and if A was negative and our graph opened down, then it doesn't touch the x-axis.
Oh, okay.
So you can do like a rough sketch of your graph. For our y-intercept, we plug in 0 for x. So we have y is equal to 2 times 0 squared plus 0 minus 3. So what does y equal?
Negative 1. No, never mind. Negative 3.
Negative 3. So how would I write that as a point?
0, negative 3.
Awesome. We plugged in 0 for x, so our x would be 0, comma, negative 3. All right, let's look at 3 right below it. So here we have to find the end behaviors, the zeros, and state the multiplicity. So our end behavior, we look at our term with the highest degree, so that would be x to the 3rd power. Is our exponent even or odd? Odd. So are they going to go in the same direction or opposite directions? Opposite. So is it positive or negative?
Negative.
Positive. X to the 3rd power is positive.
Oh.
So what does that tell us about our right arrow?
I don't know.
If it's positive, the right arrow goes up. And since they go in opposite directions, the left arrow is going to go down. Now for our end behavior, we have to leave it in arrow notation. So we have as x goes to negative infinity, and as x goes to positive infinity, then y is going to go to blank. So we can picture our graph here. Negative infinity is on the left. Positive infinity is on the right. What did we say our left arrow is going to do? Here, what did we say our left arrow is doing?
Up or down?
It's going down. So down to positive infinity? I mean, down to negative infinity or up to positive infinity?
Negative.
Down to negative infinity. Now, as x goes to infinity, we're talking about our right arrow. What's our right arrow doing? It's going up. So y is going to go to positive infinity. Awesome. Now let's find our zeros. For the zeros, we have to solve, which most likely means we're going to have to factor. So we have 0 is equal to x to the third power minus 3x squared plus 2x. What can I do to factor here?
Multiply. Oh, no.
I'm going to take out the x. Take out our GCF, which is an x. So then I'm left with x squared minus 3x plus 2. What are two factors of 2 that add to negative 3?
2 and 1.
Negative 2 and negative 1. So x minus 2 and x minus 1 and x. Find our zeros. We set each one of these equal to 0. Don't forget about that x that we took out in the beginning. So x is equal to 0 is one of our answers. X is equal to positive 2 and x is equal to positive 1. So our zeros are going to be 0, 1, and 2. Any questions here? Steven?
Does the order matter?
The order doesn't matter.
Okay.
Now our multiplicity. How many zeros do I have as an answer? 1. So I have a multiplicity of 1 at 0. Is my multiplicity even or odd at 0?
Even?
Is 1 an odd number or even?
Odd.
So odd. How many 1s do I have as an answer?
1.
1. So I have a multiplicity of 1. Is 1 even or odd?
Odd.
Odd. And then how many 2s do I have as an answer?
1.
So I have a multiplicity of 1. Is 1 even or odd?
Odd.
Odd. So even though my number was 2, my multiplicity is odd because I only have 1, 2 as an answer. Now, if we were to graph these at 0, at 1, and at 2, and my multiplicity is odd, does my graph, does the line go through the x-axis of the graph, or does it touch and turn?
Touch and turn.
If our multiplicity is odd,
Oh, so goes up.
we go through the graph. So we go through, and through. So just for fun, if we had to graph this, I'm going to put my points at 0, 1, and 2. I put the end behavior on my graph, so I have an arrow out of my farthest point to the right going up, out of my point farthest to the left going down, and through each of these points I go through the point, through the x-axis. So it'd look like this.
Is there graphing on the set?
So you need to know negative b over 2a. Should know your quadratic formula. It doesn't mean that you're going to use it, but make sure you know it. Make sure you know how to use the arrow notation for describing the end behavior. For these questions, make sure you answer it in proper notation. So domain and range have to be in interval notation. Axis of symmetry needs to be x equals. The x-intercept and y-intercept have to be coordinate points. So just make sure you use the proper notation for everything. It'll have it in the instructions on the quiz. Use proper notation. So don't forget. And then we're going to do one more of the long division just to practice. So let's say we had something like x to the 4th power minus 3x cubed plus 2x we'll just say 2x minus 4 divided by x squared minus 1. So on the outside, we have x squared minus 1. I'm going to put a 0x as a placeholder. You don't have to put that 0x there, but it will help hold the place when you are dividing and multiplying. Inside the box, we have x to the 4th power minus 3x to the 3rd power. I'm missing an x squared, so in that spot, I'm going to put a 0x squared plus 2x minus 4. So we start by dividing. X squared divided, x to the 4th power divided by x squared would be what? X squared. Then we multiply. X to the 4th power. X squared times 0x would just be 0x cubed. Again, that just acts as a placeholder, so you don't really need it on the outside, but it helps to hold the place. And then minus x squared. Next, we change the signs and combine. So change the signs of everything in this row, combine together. X to the 4th power is cancel. This would be negative 3x cubed plus x squared. Then we do it all again. Divide. Negative 3x to the 3rd power divided by x squared. So I'm taking away 2 of the x's. I'm left with negative 3x. Negative 3x times everything on the outside would be negative 3x cubed. Then this would be 0. So you could say plus 0x squared plus 3x. Then we change the signs and combine. 3x cubes cancel. This would be x squared, because 1 plus 0 would just be 1 still. And then minus x. Now we do it again. Divide. What is x squared divided by x squared? 1. So plus 1. Multiply. We get x squared plus 0x minus 1. Change the signs and combine. So x squareds cancel. This would be negative x minus 3. Next, we would divide. Can I take away 2 x's from negative x? Can I divide negative x by x squared? No. Once you run out of x's, take away. Once the part that you're dividing into has less x's than your divisor, you're done. We also ran out of numbers here. Once we finish with our constant, the rest of it is going to be our remainder. So this whole part is our remainder. Remainder, negative x minus 3. All right, so number 2, when it's in standard form, we use our little formula negative b over 2a to find the first number in our vertex. To find the second number in the vertex, we plug in that number to find the other one. So let's find our vertex. So we have a, b, and c. So negative 4 over 2 times negative 4, bless you, would be negative 4 over negative 8, which simplifies to 1 over 2. So 1/2 is the first number in our vertex. How do I find the second number in the vertex? We plug that into the x's. In the video, it talked about another formula, which is c minus b squared over 4a. If you want to, you can use that formula, but I think it's just easier to plug it into the x's. So we have negative 4 times 1/2 squared plus 4 times 1/2 plus 3. So this would be negative 4 times 1/4, which would be negative 1, plus 4 over 2, which would simplify to 2, plus 3. So that would be 1 plus 3, which would be 4. So the second number in our vertex is 4. Now, does our graph open up or open down? How do we know that? A is negative, so that tells us that our graph is going to open down. What is our axis of symmetry? X equals 1/2. Don't forget the x equals. On the test, it's going to say make sure you use proper notation. So axis of symmetry has to be x equals. The x-intercept and y-intercept have to be a point. Domain and range have to be interval notation.
Wait, why is it down?
Because A is negative.
So axis symmetry is always just what x equals?
Yep. It's always x equals the x from your vertex.
How many questions?
9.
9.
All right. So since our graph opens down, is our vertex at the highest point or the lowest point? It is at the highest point, which would be the maximum. And what is our maximum value? 4. It is always the y from our vertex or the k from our vertex. Domain is always, always, always negative infinity to positive infinity. That is going to be like a free question, no math required there. Always negative infinity to positive infinity. Now our range, does our graph open up to positive infinity or down to negative infinity? Down to negative infinity. So we start with negative infinity. And then what y value does our graph end at? 4. And the number always gets a bracket. Now for our x-intercept, we plug in 0 for y. For y-intercept, plug in 0 for x. So it's the opposite one that you're trying to find. So when we plug in 0 for y, we have 0 is equal to negative 4x squared plus 4x plus 3. So here when we solve for x, we can either factor or we can use our quadratic formula. Let's try and see if we can factor this. How would we factor?
3 to 1.
First times last.
Multiply the first times the last. Yes. When your leading coefficient is not 1, you have to multiply the first times the last. So we get negative 12. What are 2 factors of negative 12 that add to 4? 6 and negative 2. Perfect. So we have x plus 6 and x minus 2. What do I have to do next? Don't forget to divide by negative 4. Now we have to be careful with our signs here because one of the signs is going to go forward to the x, the other one isn't. So when I simplify 6 over negative 4, I'm going to simplify it to 3 over negative 2. And the negative 2 is going to go in front of the x. And then when I simplify this one, it's going to be x plus 1/2, which I would move the 2 in front. So 2x plus 1. You can always FOIL it out to check to make sure you did it right. If you messed up the signs, when you're solving, when you set them both equal to 0, it'll work itself out to where the signs end up being the right way. From here, we're going to solve, set each one equal to 0. So negative 2x is equal to negative 3, divide by negative 2. X is equal to 3/2. And then same thing with the other one, 2x is equal to negative 1, divide by 2. X is equal to negative 1/2. Now with our x-intercepts, we have to write them as coordinate points. So this is our x value, 3/2, 3 over 2. What's our y value going to be? 0. We plugged in 0. Same thing with our second point. We have negative 1/2 and we plugged in 0. So my x-intercept's going to be 3 over 2, 0 and negative 1 over 2, 0. Any questions there? What if it doesn't factor? What would we do? Quadratic formula. So our quadratic formula is not necessarily, but just in case there is one. This is your quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Let's say we did the quadratic. let's say we did the quadratic formula and underneath our radical, we ended up with a negative under it. What does that mean? Imaginary. So if I have an imaginary x-intercept, what does that mean? You don't have an x-intercept. So if you have a negative under the radical, that means there is no x-intercept. You can also kind of get an idea of that by graphing. So just to double check to make sure you did it right. If I graphed my vertex, I go to the right to 1/2 and up 4. So my point would be there-ish. And my graph went down. So I know that I'm going to have an x-intercept because I touched the x-axis. So you can kind of like rough estimate your graph just so you know if you're going to have one or not. If my graph, hypothetically speaking, went up and I had this pink graph, will I have an x-intercept? No, because it doesn't cross the x-axis. So you just write none if you don't have one. All right, for the y-intercept, what do? Plug in 0 for x. So I have y is equal to -4 times 0 squared plus 4 times 0 plus 3. So what does y equal? 3. So our y-intercept would be 0, 3. We plugged in 0 for x and got 3 for y. All right, next. Number 4. So 4, it's asking for the end behavior, the zeros, and the multiplicity. So when we find the end behavior, we're looking at the term with the highest degree. So that would be x to the 4th power. What's our end behavior going to be when we have x to the 4th power? X to the 4th power is even, so that means they go in the same direction. Are they both going to go up or down? Up, because it's a positive x to the 4th power. So when we write that in arrow notation, we need as x goes to -infinity and as x goes to positive infinity, then y goes to blank. So just in case we forget which one's which, this one kind of helps that they're both going in the same direction. But on our graph, -infinity would be on the left side, and positive infinity is on the right side. So what is our left arrow doing? It's going up. Is it going up to positive infinity or negative infinity? To positive infinity. What is our right arrow doing? It's also going up to positive infinity. So the dark blue part, as x goes to negative infinity, y goes to blank. And as x goes to positive infinity, y goes to blank. That is always going to be the same. You can write that for your end behavior each time. The difference is going to be the light blue part, like which way y is going to. So I would draw the arrows first and then figure out which arrow is which. All right, next let's find our zeros. Finding the zeros just means that we're going to have to solve. We set y equal to 0, so 0 is equal to, since we're going to have to solve, I want to make sure it's in standard form to help us solve. So x to the 4th power plus 3x cubed minus 4x squared. Tell you what, could I do to solve?
Oh, I take -4. Is that -9 or -4?
That's a -4.
Take it.
Where?
Well, like,
We want to take out our GCF, which is x squared.
oh wait, no, I wasn't going to do this.
All right. What are two factors of -4 that add to 3? 4 and -1. So x plus 4 and x minus 1. And don't forget, we also have that x squared out front. So when we set each piece equal to 0. So x squared is equal to 0, which just means that I have 2 zeros as answers. And then x is equal to -4 and x is equal to +1. So our zeros would be 0, 0, -4, and +1.
You have to put both zeros.
I would recommend putting both zeros because the next step we're going to talk about the multiplicity. So it's important to know that you have 2 zeros. So multiplicity is how many times that number occurs. How many zeros do we have? 2 zeros. So I have a multiplicity of 2. So is my multiplicity even or odd? Even, because 2 is an even number.
Oh, you can't just say like multiplicity of 2, you have to say even?
Yes. Now with -4, how many of those do I have? So I have a multiplicity of 1. Would it be even or odd? Odd, because 1 is an odd number. So we're not talking about if -4 is an even or odd number. We're talking about the multiplicity. So since I only have one of them, it would be odd multiplicity. And then lastly, how many 1s do I have as answers? 1. So I have a multiplicity of 1. Is 1 even or odd? Odd.
So you look at your answers like that?
Yes. So for each number, just describe how many you have and if your multiplicity is even or odd. You're not going to have to graph these, so you don't really need to know if it touches or turns or goes through. Just make sure you tell me if the multiplicity is even or odd. So there's no graphing on the test. So let's take a look at number 5. So we're going to look at our highest degree term to determine the end behavior. So is our exponent even or odd? Even. So are they going to go in the same direction or opposite? Same direction. Are they both going to go up or down? Up, because it's positive. So our end behavior, we'd say, as x goes to negative infinity and as x goes to positive infinity, that's just telling us left and right. It's just a complicated way of saying left and right. Then y goes to, what's our left arrow doing? It's going up to infinity. What's our right arrow doing? Up to infinity. So now let's find our zeros. I'm going to put it in standard form to help us solve. So I have 9x to the 4th power minus 54x squared plus 81. Any recommendations on what we can do first? Take out a GCF. So we're going to divide out the 9. So we're left with x to the 4th power minus 6x squared plus 9. Now here, this is super similar to x squared minus 6x plus 9, but when we write our factors, since it's x to the 4th power, we're going to write x squared and x squared. So instead of it breaking down into x and x, it breaks down into x squared and x squared. Now what are 2 factors of 9 that add to -6? -3, -3. So when we solve this, we set each one equal to 0. Well, does 9 equal 0? No, so that's not a solution. If it was an x, don't forget to set it equal to 0 and solve, but since it's just 9, we can get rid of it. Next, we have x squared is equal to 3, and x squared is equal to 3. What do we do next? Take the square root. So what does x equal? Plus or minus square root 3. So here, I have x is equal to positive square root 3, negative square root 3, positive square root 3, and negative square root 3. Because I had 2 plus or minuses of them, so I've got 2 of each, which it's important to write it twice to help you with the multiplicity. How many positive square root 3's do I have? 2. So is my multiplicity even or odd? Even. How many negative square root 3's do I have? So I have a multiplicity of 2. Would it be even or odd? Even, because I have 2 of them. Bless you. All right. Next, let's solve using long division, number 6. So long division, our divisor is going to go on the outside, 2x plus 1. And then inside the box, we put our dividend. So 2x to the 3rd power minus 11x squared minus 2x plus 2. Always check to make sure you're not missing any terms. If I start with x to the third power, I need x squared, x to the first power, and our constant. So am I missing anything? No. So we're good to go. If we were missing anything, we'd have to put a 0 in that spot. So when doing long division, step 1 is divide. 2x to the third power divided by 2x would be what? X squared. So I'm going to put that on top of my x squared term. Keep my like terms in line. Step 2 is multiply. So we multiply x squared times everything out front. So we get 2x cubed plus x squared. What's step 3? Change the signs. Change the signs and combine. So change the sign, combine. The 2x cubes are going to cancel. And then we get negative 12x squared. Now we do it all again. We divide. What is negative 12x squared divided by 2x? Negative 6x. Then we multiply negative 6 times everything out front. So negative 12x squared minus 6x. What's next? Change the signs and combine. So the 12x squareds cancel. What is negative 2x plus 6x? 4x. Back from the top, we divide. 4x divided by 2x. 4x divided just 2. Perfect. You can always tell what variable is going to come next if you keep your like terms in line. I already have an x term, so the next one's going to be constant. Then we multiply. 2 times 2x. 4x plus 2. Change the signs and combine. 4x's cancel. What is 2 minus 2? They cancel also, 0. So our remainder is 0. So our answer here would just be x squared minus 6x plus 2.
If we were to have it would be, I don't know, the number over 2x plus 1, right?
You can leave it as remainder, whatever your remainder would be. So here our remainder is 0. So you don't need to leave it as a fraction. You can just give me the r. All right, let's look at number 8. Solve using the remainder theorem. So remainder theorem, we're going to use synthetic division. And then whatever we get as our remainder is our answer. What's going to go outside the box here? Negative 2, perfect. When it has the number for us, g of that number, that's what goes outside the box. If it had x minus 2, this is where you change the sign. But when it has f of negative 2, we keep the same. What's going to go inside the box?
4, 16, negative 16.
Awesome. 4, negative 16, 5. Don't forget that we're missing an x term, so I have to put a 0 in that spot, and then 9. Don't forget about the 0. Make sure all of your terms are represented. So we're going to drop down the 4. Multiply on the outside, we get negative 8. Add on the inside, this would be 24, negative 24. Multiply, we get 48. Add will be 53. Multiply, negative 106. Negative 106. Multiply, 212. And add, 221. Awesome. So g of negative 2 would be 221. Just the remainder. When it says use remainder theorem, just the remainder is your answer. All right, 10. We're going to use synthetic division to find the quotient and the remainder. So what's going to go on the outside of our box now? Positive 3. Remember, when it's x plus or x minus, we change the sign.
So if it's x plus 3, it's x minus 3, right?
Yeah, it'd be like negative. So whatever, if it's x plus 3, it'd be positive. Well, plus 3 would be minus 3. So you just flip it.
Oh yeah. Sorry.
What's going to go inside the box?
2,
-2, 0,
0,
0.
1,
Oh, 1,
0, 3, -1.
perfect. We're missing an x to the 4th power, so I have to put a 0 in that spot, and we're also missing an x squared, so I put a 0 in that spot. We're going to drop down the -2, multiply on the outside, we get -6, multiply again, we get -18, which would be -17. I'm going to write it on the side here, 51. So this would be -51.
Yep.
-51, multiply again, 51 times 3.
153.
153, -153. Add, we get -150. Multiply should be -450, perfect. And then add, -451. Oops, here it's not asking us for the remainder theorem, it's asking us to find the whole thing.
3x for
Awesome.
3.
Since we started with x to the 5th power, our answer is going to start with x to the 4th power, minus 6x to the 3rd power, minus 17x squared, minus 51x, minus 150, remainder, -451. So I'm just going to write it to be a little bit neater. -2x to the 4th power minus 6x cubed minus 17x squared minus 51x minus 150. I'm perfectly fine with you leaving as the remainder as an r, -451. If you wanted to leave it as a fraction, you could. So the other way we could write a remainder would be minus 451 over x minus 3. Either way is fine. I'll let you decide on the test tomorrow. Yeah. So it's not really a formula, but something that you gotta know. And then those are pretty much just the formula. So if it says on the test divide using long division, you have to use long division. 3x plus 5 is gonna go on the outside. Am I missing any terms that we put on the inside? No. So 15x to the 3rd power plus 37x squared plus 53x plus 55. Step 1 of long division is what? Divide. So what is 15x to the 3rd power divided by 3x?
5x.
Just 5x? 5x squared. If you need to, write it down. I think it helps to see what you're doing if you write down what you divide. So 15 divided by 3 would be 5. And if I have 3 x's and I take one away, it'd be 5x squared. Next, we multiply. So I'm multiplying 5x squared times everything out front. So it'd be 15x to the 3rd power plus 25x squared. After we multiply, what's the next? Change the signs and combine. So this becomes a minus 15x squared and minus 25. So 15x squareds cancel. What is 37x squared minus 25x squared? 12x squared. What is 12x squared divided by 3x? 4x. After we divide, we multiply. So we get 12x squared plus 20x. Change the signs and combine. 12x squareds cancel. What is 53x minus 20x? 33? 33x. What's next? Divide. 33x divided by 3x? 11. Then we multiply 33x plus 55. Change the signs and combine. 33x's cancel. What's 55 minus 55? 0. So here our answer would be 5x squared plus 4x plus 11 with the remainder 0. I am perfectly fine with you leaving your remainder as remainder 0. If you want to just leave it as the remainder and whatever it is. When it's 0, you don't have to write your remainder, but if you had a remainder that was a number, you can write R, the number. You don't have to leave it as a fraction, unless you want to. I'm okay with that too. Yeah, we combine the terms on top. Any questions here? Good with this one?
Yeah.
All right, next we're going to talk about the remainder theorem. So when we're using the remainder theorem to solve, the remainder is our answer. So we keep the remainder. So here, I did this one in the last class. We're missing an x term, so I have to put a 0 in that spot. What's going to go on the outside for 9? For 9. 5. When it gives you something like g of the number stays the same. So use the same number on the outside, 5. If it gave you something like x minus 5, this is where we change the sign when you plug in the number on the outside. Inside our box, we have 4, negative 16, 5, 0, and 9. Synthetic division. Drop down the 4, multiply, add, we get 4. Multiply 20, add 25, multiply 125. 5 times 125 is 625. Let's write it down. 125 times 5. 5 times would be 12, 625. And 625 times 9, plus 9. Oof. 634. So when it says use the remainder theorem to evaluate, just the remainder is our answer, 634. Any questions here? Good with this one? All right, next, we're going to use synthetic division to find the quotient and the remainder. So for number 11, what's going to go outside the box? Negative 1. This is the one where we have to change the sign. Inside the box, what are we missing? I have an x to the 5th power that I'm missing, x to the 4th power, and x to the 3rd power. So I have to put 3 zeros. And what else? And another one after the 3, a 0x. So I have 5, 0, 0, 0, 3, 0, negative 1. Just be careful when you're plugging in what you're missing, especially if you're missing more than one thing. Don't rush it. We're going to drop down the 5, multiply, add, we get negative 5, multiply, positive 5, add, we get 5, multiply, negative 5, add, negative 5, multiply, positive 5, add, 8, multiply, negative 8, negative 8, positive 8, and 7. Does everybody agree? All right, if our question starts with x to the 6th power, what's our answer going to start with? X to the 5th power. So we have 5x to the 5th power minus 5x to the 4th power plus 5x to the 3rd power minus 5x squared plus 8x minus 8, remainder 7. This question is asking for the quotient and the remainder, so it's asking for the whole thing. Yeah, this part would be the quotient. This part is the remainder. The whole thing would be your answer. I don't know if it asks to separate it on the test, but just give me the whole thing. Alright, let's look at the last page. So given a vertex and the point, write the equation of the parabola in vertex form. So our vertex is going to be our h and k. Our point is going to be x and y. So let's plug in what we have. F of x is just a fancy way of saying y. So we have 7 is equal to a times x minus 2 squared plus k. Oops, x, I forgot to plug in, is negative 1. And then plus k would be minus 4. So what am I missing? A. So I need to solve this to find a. And then once we find a, we're going to plug in a and our vertex, h and k. And that'll be our equation of the parabola. So what should we do first to find a?
Solve the
Which part am I solving first?
negative 1, negative 3.
Awesome. Negative 1 minus 2 be negative 3. And negative 3 squared would be 9. What do I do next?
Divide. Okay. 9.
Before I can divide 9, what do I have to do next? Add the 4.
So it's
We're going to add the 4 to move it to the other side. So we have 11 is equal to 9a. Then we can divide by 9. So a is equal to 11 over 9. Now we're going to plug in our a, our h, and our k. So I have y, or f of x, you can leave it either way, is equal to a, which is 11 over 9, times x minus 2 squared minus 4. So make sure you know the vertex form formula.
what formulas means now? I know negative b over 2a.
In vertex form. All right, let's do the last one. Given the quadratic in standard form, write the equation in vertex form. So when we write it in vertex form, we need to find the vertex. How do I find the vertex? What's the little formula? When it's in standard form, how do I find the vertex? Negative b over 2a. So that helps us find the h, the first number in our vertex. So I have a, b, and c. So negative 6 over 2 times negative 3 be negative 6 over negative 6, which is 1. So the first number in our vertex is 1. How do I find the second number in the vertex? Awesome. We could either use that other formula or we can plug it into the x's. So I have negative 3 times 1 squared plus 6 times 1 minus 4. This would be negative 3 plus 6 minus 4. So 3 minus 4, which is negative 1.
That's it?
Nope. We have to plug it into vertex form. So we need to know our vertex. That's our h and k. Our vertex form is y is equal to a times x minus h squared plus k. So I can plug in my h and k, but I also need to know my a. How do I find my a?
You solve.
Nope.
Oh, it's negative 3.
Awesome. Our a is from the original equation. It's the same thing, negative 3. So I have y is equal to negative 3 times x minus 1 squared minus 1.
This is easy.
Okay, good.